So looking through Unit 0, we have to work through fractions. So this is the first video I've uploaded about the Unit 0 review. So go ahead and use this if you're trying to review about adding and multiplying fractions. We're going to start off by just understanding what this process is about. To complete the x by filling in the blanks, we're talking about this space up here and this space down here. We're going to fill in those blanks, okay? The way it's going to work is that we're going to write the product of the two fractions on the top, as it says right here. So that's where we put the product. Again, is what you get when you multiply two numbers. So the product of 2 and 3 is 6, okay? And then we're going to write the sum on the bottom in this blank right here. That's where we're going to put the sum, okay? And the sum of two numbers is what you get when you add them, okay? So the sum of 3 and 2 is 5, right? So the sum of 3 and 2 is 5, but the product of 3 and 2 is 6. Okay, we might sometimes just call this the number that they multiply up to, or the number they add up to, but you guys want to know this vocab too. So to write the product of these two fractions, we need to understand how to multiply two fractions together. And the idea of multiplying two fractions together, basically, we do the top times the top and the bottom times the bottom. So we're looking at this fraction, and we can see it's going to be -5 times -4. And so a negative times a negative gives me a positive. So that's positive 20. And then on bottom we have 7 times 7, and that gives me 49. Okay? Maybe that's easy, and you already understood this whole process, in which case you can maybe move on. But the thing I want to talk about very quickly is the difference between these fractions here. Okay? Because I'm assuming a couple of you guys might not understand the difference between these three fractions. Okay? I showed this to most of my classes today. I might have forgot to show one class. But what is the difference between these expressions? -5/7, -5/7, and 5/-7. The obvious thing is that the negative is in different places, right? That's the difference, okay? But the truth is that really, they're not different. These are all equal. It's the same expression any way you want to write it. So what I'm trying to get you guys to understand is that if the negative is out front, we can really treat it as if the number on top is negative, okay? And that's usually what you probably want to think about it. Every now and then, I guess it might be helpful to put the negative on bottom. But more often than not, in the math that we're doing, we're going to want to imagine that negative as the value on top of the fraction. So that means that I want you to think about this as a -5, but a +7. Okay, so this is -5/+7 and -4/7. Okay? If I decide to look at it as the bottom number is negative, then that means the top number has to be positive, right? So notice they can't both be negative, okay? So when the negative is out front, it definitely does not mean that they're both negative, right? Because think about it. What is a negative divided by a negative, right? It's a positive, because then this would be -1 times 5 over -1 times 7. And then if I canceled out the negative ones, we would have a positive value. So the main point of this little sidebar conversation that we have here is that when you see the negative out front, you need to know that it's only one of the numbers that's actually negative, okay? And don't think of it as both of them being negative. So we'll do another example of that, and I want you guys to keep everything that we talked about in mind. We'll get over here for this one, number 2. You could definitely try this in your head by now. Okay, again, the top times the top. 7 times 3 is 21. And then we do the bottom times the bottom, which is 50. So that's the way this works. We have completed the product of those two values. There's nothing else to do there, because we would say that this fraction is irreducible. Okay? Irreducible means the fraction cannot be broken down into a lower form. And also we would say that for this one, for number 1, it's also irreducible, because it's 20/49 and those numbers are relatively prime, right? So on number 3, we'll do the top times the top. So you might want to do that in your head right now. Tell me what I'm going to write down for the answer here. And I'm hoping you got the idea that this is -9/50. Okay, as we move over to this one, we have -5 times 4, and that's going to give me -20, but 6 times 5 gives me 30. So as we work through that, we see that this is not irreducible, okay, because this is like -2 times 10 over 3 times 10. And so if we cancel out the 10s, we see we're going to be just left over with -2/3. So I hope this process makes sense. Multiplying fractions is just like doing a double multiplication, okay? As I said a couple times already in the video, the way that I usually tell my students to say this out loud, because I feel like it just falls out so quickly. Top times top, and bottom times bottom. Okay, it's easy enough to remember, and so make sure that that is in your memory banks when it comes to multiplying fractions. And now we have to do the much more difficult one, which is adding up fractions. Okay, this is not as simple as you might think, right? So to add up the fraction, we're going to have to learn about the numerator and the denominator, all the names that go along with the fraction. And then we'll also have to talk about reducing them too, because most of the time it's going to be something you have to think about. So we're going to take a look at this thing, and we have the first one. We have to do -5/7. Remember, it says to take the sum. Okay, and the sum is what you get when you add them up. So that means it's telling me to do this number plus this number. So I have to put plus, and then I have to write that number. Okay, so I'm just trying to make sure you guys can see what we're trying to do. Okay, if I knew the answer to that problem, then I would write it down here in this box right here. That's where it's going to go, in that space. So we want to know that. The first thing we got to understand is, like, what does this mean, for instance? Like, if I did 3 plus -2. Okay, you need to know that adding a negative is just subtracting. Okay, so it's just 1. So what we have here can already be changed as -5/7 minus 4/7. Okay, but when you're adding and subtracting two fractions, and they have the same denominator, we can combine them into one fraction. So we'll put 7 on the bottom, and that doesn't change. But on the top, we have -5 minus 4. Now if we do this together, this is going to give me -9/7. So this would be complete. This problem is done, and I'm going to go write the -9/7 in this spot right there. Okay, and then I'm just cleaning up the rest of the marks. There you go. That's the idea. Okay, so when fractions have the same denominator, you can combine the numerator, the number that's on top. Okay, but if they don't, then you definitely can't do that. And you have to think about everything else that goes around with that. And that's why we're going to do this one over here. This is the first example that works like that. So if I'm going to add 3/5 plus 7/10, we need to find a way to get the same denominator. Otherwise, I can't do this. We can't combine the top because they're not counting the same thing. So what I show my students to do is put a blank parentheses with a blank fraction there, and we're going to write that next to the one that I want to change. Okay? The reason that I know I could do this next to 3/5 is because I know that I'm going to try to figure out, is there something I can multiply this by to get that? And then I would probably also ask myself, is there something I can multiply that by to get the other one? Okay, so you're just going to check both ways. I'm not going to be able to multiply 10 by something to get a 5. But if I multiply 5 by 2, I would get 10, right? So that's useful. Okay, so we're going to keep that. And then we're going to copy the other word, the other fraction. So now we have 3/5 plus 7/10. How do I figure out the numbers that are going to go in these two places right there? How do I figure out what number goes there? Well, what we're going to do is figure out what can I multiply 5 by to make it into a 10. And in this case, I'm really hoping you know how many fingers you got, right? 5 times 2 is 10. And on top, we got 2. So now what are we doing? 2 times 3 is 6. So see, we have to change the form of this fraction. So it used to look like 3/5, right? It used to look like that. And now we're going to change it, right? 2 times 3 is 6, but 5 times 2 is 10. So notice that 3/5 is equal to 6/10. If you go into your calculator and calculate that, you're going to see 3/5 is 0.6. And if you do 6/10, you're going to get 0.6. Okay, these numbers are the same, but they look different. And that's useful because now that we made it look different, we made it look on purpose. We wanted to have a 10 on bottom. So that means now I could put 6 plus 7 on top. And 6 plus 7 gives us 13. So our value for this one is 13/10. So again, these kind of calculations, this number sense that you really want to work through, it takes a little bit of muscle memory, I think. and after you've done a lot of more higher level thinking questions about these, it just starts to become second nature. So I'm going to say, if you are not like able to master fractions immediately, don't get too down about it, because it is, you know, one of those things that you can easily flip-flop and go backwards. Okay, instead of worrying about it, just put in the work, okay? And just understand that if you keep taking baby steps, eventually you'll look back and realize that this is easy. So we want to add up -3/10 plus 3/5. Okay, and as I said, just put the negative on top. And then let's think to ourselves, what could I do? What could I multiply this by so that I could get a 10 right here, right? What could I multiply this fraction by so that I get a 10? Well, in the last one, we multiplied by 2, so that number should be kind of familiar, right? If I multiply on top and bottom by 2, then everything is still equal because I didn't actually change the number, right? 3/5 now just looks like 6/10. You see that number is the same number. 3/5 is equal to 6/10. Okay, the numbers look different, but they're the same. And because they both have a 10 on bottom, which was the whole reason why we chose 5 times 2, now I can add the numbers on top. And -3 plus 6, right, that's going to give me 3, so we get 3/10. Okay, so right here in this spot, we should have 3/10. Okay, so after this, we'll do another little review to kind of break down the difference between all these problems. But hopefully you're following along, and we're almost ready to start practicing this on your own. So right now, let's work through this specific problem where we have to change both of them. The first thing I would do is just copy these fractions. Okay, and put an equal sign. And again, to keep everything equal, that means I didn't change anything, right? So I'm going to go ahead and put the -5/6. And then we're going to add again another blank parentheses, okay? And I'll put this over here on this side. And then we'll put 4/5. Okay? So now imagine, like the whole problem here is what numbers go into these spots right there. What numbers go there? In this case, I have to put 5 on bottom. But because 5 is on bottom, we also need a 5 on top. And in this one, I have to think again, how do I figure out what number goes on bottom here? Where do I look? Okay, you look at the other fraction and look at the denominator of the other fraction. Okay? So I'm going to put 6 here. And since 6 is on bottom, 6 also has to go on top. Okay? If you start doing enough of these problems, which is one of the problems of not doing your homework, you won't really learn anything. You'll be coming to school and it's kind of for nothing. Okay? You got to do that learning so that you kind of actually get this in your long-term memory. So 5 times -5 is -25. And 6 times 5, right? Bottom times bottom is 30. Okay? But notice how this one is also going to work out to be a 30. Okay? Is that a coincidence or did this happen on purpose? Like, you really have to realize that we're making a plan every time to get this number to be the same denominator with the other number. Okay? So in this case, we had to change both of these fractions, right? 6 times 4 is 24. And then we'll do this calculation over here on the side because we have 30, and we know that -25 plus 24. My students might mess this up, okay? Think about it. Which number is bigger? Right? The number that's bigger is the negative. So that means we're going to have -1 on top, okay? So our final answer for this one is -1/30. And that's us doing all 4 of those problems. So now what I want to do is I'm going to make a new tab, and we're going to talk about the difference between those 3 problems. I had a good conversation with the student toward the end of the day. They asked a good question, and I think I found a pretty efficient way to show the answer. Okay, so let's try to do this real quick. Let's do 1/4 plus 2/4, right, in this case. Okay, so in this case, we don't have to change the denominator. Okay, so in this case, we can say there is no need to change denominators right when we add them because they're already the same, right? You can see that they're both a 4. So There's no need to change the denominators. Get it? So now what I want to do is talk about what happens when I have to change one of them. Okay? Let's go ahead and say that we're going to do, let's say, 3/5 plus 4/10. So when we put this together, we need to change one of them, right? You should identify this. In this case, we need to change, okay, the smaller one into the bigger one. The smaller denominator is what I mean. 5 is smaller than 10. I need to change the 5 into a 10, right? We need to change the smaller denominator into the bigger one. Okay? And the reason we could do that is because we see that 5 is a multiple of 10. That's not always true. So in this case, we only have to change one of them, right? So how would that look? Okay, well, let's do what we did last time, where we put our little blank, and then we copy everything else. We got 3/5 plus 4/10. Well, again, how do I figure out? Well, it says we need to change the smaller denominator into the bigger one. Okay, so I need to change 5 into 10. And we need to do that with multiplication. So what do I multiply 5 by to get 10? I have to multiply it by 2. And because that's a 2 on the bottom, we have to have the same thing on top. Otherwise, if we don't do that, it's not equal anymore. The only way that you can multiply something by a fraction and have everything be equal still is if that thing you multiplied was 1. All right? So let's finish this up. We have to do the top times the top. And what's that make? The top times top is going to give us 6, right? On bottom, we get bottom times bottom, and that's 10. So we got 6/10, right? Probably shrink this down a little bit. And then now we have to add 4/10. Okay? But because they are both with the same denominator, we could add the top. Okay? And that gives me 10/10, which we know is the same thing as 1. Okay? So sometimes you only have to change one of them. And that's only going to happen when one of the denominators is a multiple of the other denominator, right? So in this case, 10 is a multiple of 5. So that's why it's possible to multiply 5 by 2 to get 10. Now let's talk about the third situation. The worst situation you could have is when we have to change both of them, right? So what if I had to add 2/5, okay, plus 1/4? Okay, now 4 is not a multiple of 5, and 5 is not a multiple of 4. So in this case, we have to do what? We need to change both denominators, okay? So how's that work? We're going to write an equal sign. And then a lot of this is muscle memory just from doing so many exercises. You guys will develop that, okay? I'll put the blanks in front of the fractions, okay? And we see we're just going to change them. So what should I do? How do I figure out what number goes in these two spaces? All right, well, one thing I've been doing is showing color to try to get my students to see this. So if I change that into a 4 and make it red, and if I change this 5 blue, I'm hoping your eyeballs can start to see what I'm looking for, okay? Now notice this 5 is blue, right? So what I want to do is use the other color. So the one that's going to go with it is the red one, okay? So the 4s need to go there, get it? What has to go here? And I guess I could color in these two, and that might help you see it. Okay? So notice, I need the two different colors to go together. Making sure I have red and blue and red is going to make sure that we have the correct denominator that we need, right? So what should go in this case? Well, I look for the blue number, the other one on bottom. So that's going to be 5 on top and bottom. Okay, and when we make this happen, we're going to get over here, 4 times 2 is 8, and then 4 times 5 is 20. So we got 8 20ths, and then 1 times 5 is 5, and 4 times 5 is 20. So we got 8/20 plus 5/10, And then I'll erase this little fact. I hope you guys have that written down somewhere to understand the difference between these. Okay, so these are the 3 ways that the problems can work out. We got 20 on bottom, and on top we would have 13 again. Well, I did kind of skip a step, right? I would have had you guys probably write 8 plus 5, but we know that that's 13 over 20. I hope you guys can understand the difference between these 3 problems, okay? Sometimes there's no need to change the denominator. That's when they're the same. Sometimes there is a need to change the smaller one into the bigger one, and that's going to be when one of them is a multiple of the other one. When neither of them is a multiple of each other, that's the least convenient situation. That means we have to change both of these into a new form, and then we can add them up together. So your homework was to get through this part, and I feel like this video is at a good length right now. You guys should be able to take that and run with it to help you out through these, okay? So try to finish this up. This assignment is going to totally be due in a few days. But if you don't chip away at it and do the little pieces that I meant for you guys to do, then you're going to have a lot and be overwhelmed maybe. Okay, so please get up to number 12 so that you're done with the fractions, and we'll be ready to move on to the next section tomorrow. I hope this helps out you guys. All right, good luck studying.